I want to show you the method of substitution. So suppose you have limit x going to 0 of sine 3x over 2x. Right. It's very tempting to move the 3 outside, but that's not allowed, right? For a sine function, you can't do that. In fact, most functions, you're not allowed to bring numbers like this outside. So it's totally, this sine 3x is totally different from 3 sine x, right? So this sine 3x is something you can't do. And it's very annoying because if that wasn't there, think about this. If 3 wasn't there, what's the limit? It's just sine x over 2x, so sine x over x gives you 1, and there's a 2 left, so it'll be 1 over 2. Right? It will make life a lot easier if I could get rid of 3. That's when you use substitution. If you look at something and I want it to look like something else that you already know, one way to do it is to use a new variable, say t equals to 3x. And then using this substitution, we can completely change this limit into something else. So here's how you do it. If t is equal to 3x, then what is x equal to? Can you solve this for x? T over 3. So that's one thing. And another fact is that as x goes to 0, t goes to where? If x becomes very close to 0, what happens to the value of t? T goes close to 3 times 0, right? If x becomes 0, t becomes 3 times 0. What's that? 0. So as x goes closer and closer to 0, t goes closer and closer to 0. And that's all we need in order to do the substitution. So x going to 0 is now changed into t goes to 0. This 3x is now substituted into t because that's what that was the original purpose. We just wanted sine of t only. But then what do we do with this 2 times x? X is t over 3, so I can replace x by t over 3. And then you can multiply 3 top and bottom because I don't like fractions inside fractions. So I get limit t going to 0 of 3 sine t over 2t. And now what's the limit? We see that this is really limit of t going to 0 of 3 over 2 times sine t over t. What's this limit? Sine t over t as t goes to 0, what's the limit?
1.
It becomes 1, that's what we have up here, and therefore 3 over 2 is the limit. Okay, actually, I want to mention this. I want to mention something extra. We'll do some more substitution examples. Let me say something. So, when you say limit of x going to 0 of sine x over x is 1, this really means that the value of sine x over x is very close to 1 if x is close to 0. If you have an x value that's very close to 0, the value of this fraction will be very close to 0. Okay. Now we can further say that another way to state this is we can also say that once you multiply x both sides, you can say that sine x is very close to x if x is very close to 0. And you can actually verify this by using your calculator. So if you set your calculator to radian mode and say if you did sine of 0.0123, something like this, then you will see that the value that your calculator gives you is like 0.0122, something, probably 8 or 9, something very close to this. Yeah, that's true. If you have a calculator, you should try this. Okay. So the value of the sine of x is very close to the x itself. It's just, usually it's just slightly less when this value that you're plugging in is very close to 0. This is very close to 0, right? So if you had that thought, then actually the previous question can be done a lot easily. So another way to think about the question that we just solved is like this. Sine of 3x over sine of 2x, no, just 2x. This was the problem that we just solved. See, sine 3x, because x is very close to 0, 3x is also close to 0. If you have something that's very close to 0 plugged into sine, that's like the thing that you're plugging in. So see, sine of 3x is very similar to just 3x. The top one is very similar to 3x. Therefore, if you set the limit x going to 0, they're going to be equal. And after that, if you cancel the x's out, you end up with 3 over 2. So that's another way to think about it. And once you think in these terms, you can do a lot more examples. So let me show you another example. Example 6, say limit x going to 0 of sine 3x over sine 7x. What's the limit? Well, sine 3x is close to 3x, and sine 7x is close to 7x, so when you take the limit x going to 0, you'll end up with 3 over 7. That's another way to think about it. Actually, this is not a proper mathematical argument, because in limits, there could be a lot of surprises. This gets the job done, but some professors do not like it this way. If you really want to solve this in the proper way, let me do example 6 in the proper way. Usually, they want you to do x going to 0, sine of 3x over sine of 7x, as a limit x going to 0 of sine 3x over 3x, 7x over sine 7x, times 3 over 7. So these two are the same, because you can see 7x, 7 cancels, 3 cancels, x cancels. After canceling everything, these two are the same thing. Now why did I do this? That's because if you have these things the same, this will converge to 1. That's going to converge to 1, and that's 3 over 7. That's how you get the answer. This is a perfect argument. There's no way to kind of argue against this result, whereas this argument seems to skip some things. So some professors prefer this over that, and I believe the textbooks use this too. They give you the same answer, then I wouldn't mind doing it this way.